Okay, so this is a qualitative example problem, right? So we have example 2, a storm is producing waves off the coast as shown below. Which direction would longshore transport occur as a result of this storm at points A, B, and C? Where would you likely see the largest amount of sediment movement because of longshore transport? All right, so my drawing is not to scale and not as good as the one on the PowerPoint. So I would recommend you have that up separately from this while you're listening to this to get a better idea of what the picture looks like. So we've got these waves coming in from the east or from the west, coming in towards shore. We're trying to figure out what direction the longshore transport is going to be. So we have these waves being made by our storm, and here they come in towards land, right? Now, eventually, they're going to get towards land, and you're going to start to have refraction, right? That's going to start bending the waves like we talked about in lesson, I think it was 11. However, if we just want the direction of longshore transport, it's a little easier and we don't need to look in super detail at what's happening, right? So we have these waves and they're coming in towards point A, right? And so if the waves are coming like this way, they're going to drag the longshore transport down the beach to the northeast, right? Likewise for B, waves coming in based on the angle of the shore, it's again going to push longshore transport in that north or northeast direction, right? However, with C, the waves coming in on the other side of that point that's between B and C, the waves are still going to be coming in and they're going to push more in that southeast direction, right? So hopefully that was pretty intuitive. Now, the next question is, where would we likely see the largest amount of sediment movement? So remember, the two things we have that affect the amount of longshore transport that you get are first, the wave height, and then second, the angle that the waves come in at. Right? So if we're looking at B, if we look at the direction that's perpendicular to the shoreline, the waves are coming in pretty close to directly into shore, right? So that's going to mean that the longshore transport, the amount of sand that gets pushed down the beach by these waves, is going to be relatively small. However, if we look at both A and C, we can see that the waves are coming in at much steeper angles compared to the direction that's perpendicular to the beach, right? So they're both going to have larger amounts of longshore transport. And then in the determination of A versus C, as in which one's going to have the more longshore transport, well, that's going to be based on the amount of refraction that's going to happen as the waves come into shore, right? So if we look at kind of the bottom contours as they're going to appear along the coastline for C, right? The waves are coming in at a pretty steep angle to those contours, so there's going to be a decent amount of refraction, and the waves are going to bend more, right, to make them more parallel to shore, right, so that they're not going to come in at a super steep angle to C. However, if you look at A, because it's so close to the point, right, there's not going to be as much bending as those waves come into A. So you would expect a larger amount of longshore transport at A because the waves would still stay at a larger angle to the shoreline.